one of the errors that I've seen, and just few of you that had issue with this investigation or startup, is that when you do your long division, by default, you have to always subtract. So what most of you were doing is maybe 0x cubed and some minus x squared, minus x cubed, then you wrote minus x cubed. No. You are not adding like that. By default, there's a minus here. So whatever you need to do, if you are thinking adding vertically, you should be thinking adding the opposite sign here. So what I did while learning is to always put the minus here. So I go through the long process of saying 0 minus minus 1. Okay? It will always happen, but you have to always be careful and always double check. And clearly we can see that the remainder here is P1. The remainder here is also that. But what does this really mean? That's why we are looking at this now. If f of x is a polynomial, and we are dividing by x minus a, the remainder is always f of a. What does this mean? From what you have done in that investigation, your f of x, when divided, you had something like this. You had f of x here, right? There's a quotient, there's a divisor, right? And at the end, you got your remainder, right? From what we did previously, any polynomial can always be written as quotient times divisor plus remainder. Is that not? May I? Just a simple explanation. I just call it proof. It's not really like a big thing. Okay. Since our polynomial f of x, we can write it as the quotient times divisor plus remainder, if the remainder is a function in general. In this case, our f of x can actually be written as, we only know our divisor. We don't know the quotient, so maybe I write it this way. Quotient times x minus a, that's all we know. We don't know this, so we just call it q of x. It could be anything, right? Plus the remainder. The remainder, could be a number. In this time around, it's a number, so I'm just going to say r. Okay? What happens when we evaluate f of a? It will be q of x, a minus a, plus r. And what is left is what? R. Which means, whenever you have a factor, not just a factor, a divisor, because it may not be a factor. When you have a divisor, put that divisor to be equal to 0. The value of x you get, substitute into the polynomial, and your the final value is the remainder you will have gotten if you go through the long division algorithm. I said that again. You have a divisor. Okay, most of the time linear. Okay, you have a divisor. It could be quadratic, which means you have to factorize it with linear factors. We'll get to that in a bit. Equate it to 0. Get your x is equal to the other value, which is just the opposite sign of what you're looking at. Substitute into the polynomial. What you get is the remainder that will have been obtained had you gone through the long division algorithm. And this is what we call the remainder theorem. Okay? Now, when do we have a factor? In numbers, in functions, anything. You divide, and you say, oh, this divisor is a factor. Why do you call it a factor?
0 remainder.
Say that again?
0 remainder.
0 remainder. What do we say our remainder is? F of a. So by factor's theorem, if f of a is equal to 0, then x minus a is a factor. And that is all about factor theorem too. So if your question says, oh, x minus a is a factor of this polynomial. X minus, maybe x minus 1 is a factor of this polynomial. X plus 3 leaves the remainder of this when divided by whatever. And the polynomial has two unknowns. You'll just be given the information to formulate a quadratic equation, a simultaneous equation. That's it. Using both factor and remainder theorem. And that's what I want us to focus on together as we do this. Alright, so let's write this first.
Wait,
Yes, sir.
no, but Q should be Q bracket A. No, I'm just saying.
Speak louder, I can't hear you.
I'm just saying for the second line, for the third line, Q should be Q A, not QX.
Q? Oh yeah, it should be QA, yes. Because we have not substituted, yes. But I guess I missed that part because I was really just focusing on what this is 0. Yeah, it's right. Okay, so this implies f of A is equal to remainder. And this is what we call the remainder theorem. Okay? Now, if we have a factor when the remainder is 0. So as a result, if f of x is a polynomial with factor x, let's say minus b, so I use a different stuff with the factor that, then f of b has to be 0. Because what you're trying to do here is to find the remainder when f of x is divided by x minus b. And we already know, because it's a factor, the remainder will always be 0. So the remainder is not an unknown this time. Okay, unlike here, the remainder is r, whatever r is. So, these are the two that really will help us, even in factorization of polynomials. Let's see. So, everybody look at your textbook. Exercise 5F on page 125. Are you there yet? I need you to do 2C and 3A. 2C and can you do 3A quickly? 2C and 3A. Is there a table with no textbook? Leo, where's your textbook? Good. Anyone? Alright, good. Everybody's good. Yes.